So section 6.2 is almost identical to section 6.1 in terms of the fact that we are using an interest equation, okay? The only thing that's different is we are introducing something called the natural base. So this thing is called the natural base, and it is E. So the natural base is E. On your calculator, you can find E where the division symbol is. So on your calculator, you can find E where the division symbol is. Now that, so you hit second and then the division symbol. If you don't know where that is, it's right here. This one, the division symbol, it is division, right? I can't tell up here. I think it's division symbol. So second division symbol, and that will be E. When you hit enter on E, you will notice that E is 2.718. It is a number. E is a number, not a variable. E is very similar to pi, okay? In case you're interested or curious or whatever about what E actually is calculated like this. So that is how E is actually calculated and figured out. E is actually kind of like a function where you can keep plugging things in and solve things, but that's what it really looks like. So if you were to calculate E, that is how you would be able to calculate E. That's what it really stems from. Okay? So this idea is a big calculus idea. Okay? So if you're interested as to why E exists or what E actually is or how we can use E, then take calculus and we'll talk about it then. We don't have the knowledge to really comprehend what E is at this moment, but E is used in a few formulas. So just understand that if you want to know more about E, take calc next year. We'll talk about it. It introduces the idea of something called limits, and limits are a big, big calculus idea. Okay? Most of you don't care. Most of you hear the words, okay, E is equal to about 2.7. That's good with me. Let's run with it. Okay? The same exact way that when you're in geometry, 90% of you don't know that pi is the relationship of the diameter of the circumference of the circle. You just know that pi is 3.14. You plug it into your calculator, hit the enter button, and move on. Right? E is kind of used the same exact way. If you want to know more about it, we can talk about it. But since most of you don't care and shouldn't care, it's not really that big of a deal. Okay? What you can kind of see, though, as you look at this, is the reason that this is going to be introduced into our formulas that we're going to be using today is this thing right here, this stuff in parentheses, looks very similar to one of the things that we did yesterday, right? Yesterday, you remember we had the formula A equals P times 1 plus R over N to the NT power. That looks pretty similar, right? That's why we're going to end up using E. Now, the reason that we use E is because of something called continuously compounded interest. This is a really hard concept for a lot of people to grab, so I'm going to try to dumb it down and make it seem a little bit easier than it actually is. Basically, what this is your interest is calculated non-stop on an account. Okay, so your interest for an account will be calculated non-stop, which means that every time you make a transaction, interest will happen to it. Okay, so like I deposit something, I get interest. Then I deposit something again, I get interest. Then I deposit something again, I get interest. I don't wait until the end of the month. I don't wait until the end of the year. Interest is calculated continuously. Now, this is not something that a lot of places offer because it sounds like a pretty good deal, right? So this is not something that really gets offered very much, but it is something that interest just continually gets calculated. It really never stops calculating your interest, okay? So that being said, when you're working through this, just understand that it's a type of interest that is basically calculated every single time a transaction is made, okay? So before we actually get into the formula, the graph of this thing looks just like this. Y equals e to the x power. Okay? This is what I meant when I said this is kind of like a function. This is absolutely no different at all from what we did yesterday when we said y equals b to the x power. Remember how we said that e was a number, 2.7? The general formula for an exponential growth or exponential decay just has b there, right? Like this table, if I ask you to graph this, would be 0, 1, 1b. This one is 0, 1, 1, and then our b value is just 2.7. It's absolutely no different than y equals 3 to the x power, or y equals 1/2 to the x power, or y equals 10 to the x power. E is just a number. It doesn't change anything. So if I ask you to graph something with E, instead of using a b value, like a random b value, you just use 2.7 as the b value, and then everything else stays the exact same. So absolutely nothing will change from graphing this to graphing this, other than the fact that your b value is 2.7. Okay, so it shouldn't be something that we even have to spend too much time on. All right. So the big part of this this kind of lesson is the fact that a equals p times e to the RT power is our new continuous compounded interest equation. Now remember, the last slide, or the slide before that I showed you, is that e is about the same thing as 1 plus 1 over x to the x power. Now that kind of makes sense, right? If I were to replace e with something that looks like 1 plus 1 over x, that looks very similar to what we did yesterday. So that's where that thing comes from. The e is really nice because it's approximated on your calculator, and you can use your calculator to use it, which actually makes your work a lot less. Okay? So all of the things stand for the same thing. A still stands for the final amount. P still stands for the principal. R still stands for the rate, and T still stands for time. A lot of people try to replace E with something. They try to plug something in for E. Remember, E is a button on your calculator. Don't do more work than you need to. The other thing I want to show you is on your calculator, you'll also see an LN button over on the side. On that LN button, if you hit the second button and then LN, you get E raised to a power. That's just a nice shortcut that you can use if you'd like to use that shortcut. Okay. So if you hit second LN, it will allow you to raise E to a power. So you remember in this formula, it says E to the RT power. You could just plug in whatever your rate is, whatever your time is to enter, and you've already done a lot of the work for you. Okay. So let's go through an example. I'm going to let you guys try this example because it's really just plug and chug. But what I'm going to have you guys do is I'm going to have you compare what happens when you have a continuously compounded account and a compounded quarterly account. So you can see the difference in what it looks like. It's not super huge, but it is there. All right. So let's say that you deposit $4,500 into an account that pays 5% interest annually. How do you spell annually? Is it 2 N's and 2 L's? That looks weird to me.
I know. I would guess no.
You know what word also looks weird to me is the word 8. Like when you spell 8 out, I don't get it. E-I-G-H-T. Like if you just look at E-I-G-H-T, that doesn't look like it should spell 8. Apologies.
I think 8 is weird.
Compared to some words, it looks more normal.
8?
Yeah.
I don't think so, man. I think English would be a hard word to learn, or hard language to learn. All right.
I mean, it definitely is.
Yeah. So deposit something $4,500 into an account that pays 5% interest annually. Now you're going to do two things. You are going to find the total after 10 years. When this is compounded continuously. And then the second one, you are going to find the value, or find the total after 10 years when it is compounded quarterly. So I want you to try both of these. You should have the tools in your toolbox to solve both of these problems without any examples. All right, so as we work through, you should realize that obviously one of them is pretty clear what your formula is going to be. If you see the word continuously anywhere in the formula, you are going to use the compounded interest equation. Okay, so if you see this word continuously, you need to make sure that you're using the compounded continuous equation, which has the E in it. Otherwise, you can't do this problem this way, because you need to know how many times it's compounded, and if it's compounded nonstop, then it's kind of tough to figure that out. So I know that I'm going to have to use the A equals P times E to the RT. 4,500 is my principal. Times E, I don't plug anything in there, and then my rate still has to be changed to a decimal, and then I'm multiplying it by 10 for the 10 years that I'm plugging in. Okay. Now, me personally, I really enjoy, I shouldn't say I really enjoy, I prefer to type things into my calculator individually. So I like to just plug small things into my calculator at a time and then keep like working my way out. So like I would do 0.05 times 10 and then E raised to that number. And then that number times 4,500. Instead of typing it all into my calculator, because I've seen a lot of things happen over the course of the last couple of months where you guys trust your calculator a lot, you type something in and then parentheses or negatives or whatever don't work out. So just make sure that you're careful when you're doing these. So I would do this as E to the 0.05 times 10. So E to the 0.05 times 10, I would hit enter on that number and then I would multiply that number by 4,500. Now, obviously this doesn't seem like a big deal. And I'm gonna be very straightforward with you when I say, do you remember in chapter 5 when I made a big stink about something and I said, this is something that everyone's going to do, write it in red, circle it, put a star by it, don't let it be you because it is something that's going to happen. I counted 27 times that I marked that wrong on this last test. 27 out of however many people had took the test, 27 people made the mistake that I said, don't make this mistake when you're taking your test. It had to do with foiling, you know, when you square on both sides and you have to foil it out. 27 people made that mistake, 27. This is one of those things that I'm telling you, it's not a big deal, and most of you probably don't think it's gonna be a big deal. This is one of the things that I take points off because they don't follow their calculator's appropriate order of operations, or they just type it in wrong. This is a very easy section when you know how to use your calculator. It becomes very complicated when you don't, okay? So my answer to this one is $7,419.25. And then we should be able to figure out what the total is when we compound it quarterly using the equation from yesterday. So the equation from yesterday was A equals the principal, 4,500, times 1 plus my rate, which was 0.05 over n, which is 4 for compounded quarterly, and then 4 times 10. This is the one that I'm being a little bit more, this is the one I'm a little bit more strict on when I'm using my calculator, because I'm not ever sure if I use enough parentheses. I'm not sure if my calculator follows order of operations the way I intend it to follow order of operations, so I force it to. When I force it to follow order of operations, I will do 0.05 divided by 4. Then I will add that number to 1. Then I will raise that number, and this is where things happen, where people will see things like this, where we multiply it by 4 times 10. I'm not positive, and I actually don't know the answer to this. I don't know if this is going to give me the right answer, or if it's going to take 1.0125 to the 4th power, hit the equal button, and then give me times 10. So if I do this, it looks like it did the bad thing. So what I want it to do is 1.0125 raised to the 4 times 10 power, and now I should get a better answer, okay? That's what I'm talking about when I say your calculator might not follow what you intended to follow. And this is something that I can see a lot of people doing in here, just because it's quick and it's easy. But your calculator doesn't follow the order of operations the way that it's meant to. So, times 4,500 for our principal. Okay, that's a lot. That was interesting. I'm going to divide that number by 100 because I apparently hit like 15 zeros. So it is $7,396.29. Now you can see the difference, right? It's about 200 bucks. The difference between being compounded continuously and being compounded 4 times in a year is about $200. $20, sorry, $20. So, so it's about $20 difference, which isn't that much, but if you have the choice between having $20 extra in your bank account and not having $20 in your extra in your bank account, you would probably choose the extra $20, right? So that's the difference between the two. I don't think it's going to be too tough. I don't think that there's too much going on with it. I think that you guys should be okay with it. Does anyone have any questions or issues that they would like to talk about this? That is section 6.2. Pretty quick, hopefully pretty easy. Hopefully it's not something that was too big of a deal. Any questions? All right.